All right, today we're going to break down something that is, well, it's both fascinating and kind of scary. It's a vulnerability called the video LLM token flood. And the wild part, it can completely paralyze an AI with something ridiculously small.
So, let's just jump right in with a question. A big one. What happens when an AI that's supposed to keep us safe, the kind making those crucial split-second calls, just freezes up?
And to really get why that's so terrifying, we need to picture a real-world situation. A high-stakes one, where this kind of freeze-up isn't just an error, it's a catastrophe. Okay, so picture this. You're in a self-driving car. It has this incredible AI co-pilot that's not just driving, it's seeing the world, understanding everything around it, and it's designed to make those life-or-death calls in a blink. And then, at the worst possible moment, that AI just goes dark. It's totally unresponsive, frozen. And we're not talking about a delay of milliseconds here. We're talking about precious, dangerous seconds ticking by. So what on earth could cause a failure that complete?
Well, the answer is what makes this whole thing so alarming. It's not some super complex virus or a huge cyber attack. Nope, it's something way, way smaller. Let's take a look at this invisible weapon.
So to paralyze one of these super advanced AIs that can see the world around it, it turns out all you need is this. Yeah, a tiny little patch of pixels. You'd barely even notice it, just sitting there in the corner of the video. That's it. That's the whole weapon. Okay, so how in the world does a tiny digital smudge trigger a complete system meltdown? To get that, we've got to look at the mechanics of what the researchers are calling a token flood. And when I say tokens, just think of them like pieces of a word. They're the basic building blocks that AIs use for language. The fancy name for this is a VidDoS attack. That's short for video denial of service. And what it does is it uses that little patch to basically force the AI into a state of, well, total computational exhaustion. It just overloads it until it effectively shuts down. So here's the play-by-play of how it works. First, the attacker sticks that tiny static patch. We're talking just 48 by 48 pixels into the video stream. Next, that patch is cleverly designed to be like a magnet for the AI's attention. It literally hijacks its focus, and the AI can't look away. Then, because its attention is trapped, the AI just starts spitting out an endless, meaningless stream of text. And finally, and this is the really clever, nasty part, the patch is built to stop the AI from ever giving a simple, short answer. It can't even tell itself to just stop. And this slide right here, it shows the damage perfectly. So normally, you ask the system, does this require manual takeover? And you get a simple, one-word, one-token answer. No. Easy. But under attack, that exact same question triggers this uncontrollable flood of over 500 tokens of just nonsense. And all that garbage text forces the AI to do a ton of extra work, totally bogging the whole system down. Okay, so let's talk about how this little trick snowballs into a huge, real-world problem. Because the impact here, it's not theoretical at all. The numbers are actually pretty staggering. First off, the attack forces the AI to generate over 200 times more text, more tokens, than it normally would. That is a huge, completely unnecessary workload. And all that extra work has a very direct, very real consequence. It basically grinds the system to a crawl. We're talking a more than 15 times increase in how long it takes to respond. Now, what does that mean in the real world? It means a delay of over 2.7 seconds. And if you're in a self-driving car moving at highway speeds, well, 2.7 seconds is an eternity. It is way, way beyond any kind of acceptable safety limit. You know, the researchers who found this put it pretty bluntly. They said this delay, this induced latency, isn't just a lag. It actually blocks subsequent frame processing. It causes critical safety violations, and it straight up neutralizes the system's operational availability. To put that in plain English, the AI becomes completely useless.
So you're probably wondering, all right, is this just a bug in one specific model, or is this a bigger, more widespread problem for these kinds of AI systems?
Well, they tested this and found it works on several pretty well-known models. But here's the kicker. The researchers warned that the problem is more fundamental than that. It could affect any video LLM that processes visual information in a similar way. That makes this a potential vulnerability for a whole class of AIs. And all of this really leaves us with a huge question, doesn't it? As we give AI eyes to see our world, to interpret it and act in it, how do we make sure it isn't so easily blinded? How do we protect these systems from something as simple as a tiny, malicious patch of pixels? And that's our look at the video LLM token flood. Thank you so much for watching.